Hello and welcome to another episode of Modular in a Week. And we are still on day 11 doing inputs and controls. And in the last episode I combined two ways of getting gate input, a button and a foot switch. And in this input I'm going to combine three things of getting a CV input into the mixer. So a module I've wanted to do a long time is a joystick, and so joystick is basically just two potentiometers that is in a XY configuration, and I really wanted to do this one because every modular needs a joystick. I'll go talk more about these ones in a bit. And then I salvaged an old keyboard and I actually got one of those pitch bends out of that, which is a potentiometer. And looking around at circuits of getting basically a joystick in, they all end up with something called a scalar circuit or scalar bias circuit, scalar offset circuit, which I actually did in the first week of Modular in a Week, but I never did a video on this because I didn't find a day that it was suited in. Now I found a day that this is suited in. So the scalar offset circuit takes an input CV signal, and then you can choose how much of the signal you want, the CV amount or the scale of the circuit, and the offset or bias, that is where you want the center frequency of the whatever CV input you have. So between minus and plus voltage. This one I also prepared with loads of diode holes for adding an LED meter, which I will not do today because the only way I've figured to do this in a somewhat exact manner is with comparators and voltage dividers, and there would be a lot of them in this case. So I'm not going to do that. But basically when you have, so if we take the joystick, what you have here, one of the potentiometers, you have plus and minus voltage on them. You get that into the CV input of an offset scalar, and then you get whatever CV signal out. And if you look at all the modules out there for the joystick modules, for example, you will see that they have an offset and an amount pot, and then they have the joystick. So that is basically it. So I'll show how to make a CV offset scalar circuit, which is a really good circuit to have, and then I'll show how to add a potentiometer to make a joystick or a pitch bend or whatever pedal. You have those expression pedals, could also be if you want to use your feet for your CV. I'm not going to show that today though, for example. So before we do that, I'd like to say thank you to my patrons who support all my work and stuff that I do here. Thank you so much, guys. You are amazing. And anyone who wants to join the gang, head over to Patreon and take a look there. So let's go and pick that up and then look at how we can do this circuit. Let's start by looking at some schematics, and we begin with the simplest one. So here's, if you search for offset scalar or CV scalar, CV offset scalar, you will find a bunch, and here is one. They all look kind of the same. And you will recognize this if you have looked at the summing mixer schematics from one of my videos, and the module I made, the ASMR, is also very similar to this, where you have multiple inputs going through a resistor to the inverted input of an op-amp, a feedback resistor, and then goes into another inverted input and another feedback loop with a similar resistor, and to the output. And if you put a output here, it is of course an inverted output, and here it is a non-inverted output because you invert the signal twice. The differences here that makes this circuit from a simple summing mixer to a offset scalar is, first of all, you have a potentiometer here, which is the scale function. So with this you can go, we have 10K here input, so we can go below 10K and we can go above 10K. So we can both lower the signal and gain the signal. So that is the gain input of the circuit. And down here, so here we have the input, and then we have another summed with the input is the offset, which is another potentiometer between plus 12 volts and minus 12 volts. So that here is a fixed value that you can just input to whatever value you have in here to either lower or raise the offset, the middle point of this CV signal. So a very simple circuit to make, two potentiometers. Here's stereoping's version, offset and scale input, and yes, both inverted output, and also a little VU meter, so he knows in the ballpark where he is in the voltage that comes out. So I just want to show, here's another schematics for offset scalar, just a few different resistor values, otherwise it is very similar. Here they also have a capacitor in the first summing circuit. But we want to have a joystick input, and basically what that is, so this is the CGS joystick controller, and if we look at this schematics, we see here is the range or scale circuit, and goes in here to the, so here's the summing mixer, inverting summing mixer into another inverting summing mixer. And here is also the offset, just like the scalar offset circuit. And then the other input, where in the offset scalar circuit we just have an input. Here we have a joystick, which is just another potentiometer, basically. So this is how simple the schematics for a joystick controller and or portamento and all those other circuits. Looking at some others, this is the Witch's Brew, which I think is Circular Electronics. He recently did this one. Same thing. Summing mixer, range, offset, and a joystick. So here's the thing, they all seem to have the same value as the joystick in series with the potentiometer to 12 volts. For the CGS04 CGS joystick controller, it even says that it uses two DC mixers, PCBs, one per axis. So very much just mixers that is just with a couple of potentiometers. Alright, so we're gonna build one of these CV offset scalars. We begin with just making this circuit, and then we add the joystick and or portamento potentiometer after that. I don't know if I showed this, but I've already built one that I also had the thought of having a meter as well, which I haven't implemented. But this is this circuit, and what I want to say is, if we want to use it with a joystick, you need to have one of these circuits for each axis. So one for the x-axis and one for the y-axis. For the portamento, you only have one axis because you only have one potentiometer. So there you only need one of these circuits. Another factor you can add is, so this one uses a TL072, and both the joystick and the portamento has a center position that you then go up and down. And with the TL072, you have you can go both plus and minus voltage. If you want a modulation wheel or something similar that you only want to have from 0 to 5 volts, or if you want joystick and this to just be from 0 to 5 volts or 0 to positive voltage, you can use an LN358 here instead, for example. But we're going to use it with both plus and minus, so we are going to use the TL072. So let's build this. Alright, so this took 20 minutes to solder together two scalar units. I have not attached any of the potentiometers, because now comes this. Now we want to attach the joystick instead. So, and if we look at one of the joystick schematics, simply put, instead of a jack here or here, this is the offset. So instead of a jack here, we just add the middle pin of one of the joystick axes, and then 1, 2. In this case, he uses ground and plus 15 volts. But so what we want minus. So we add a couple of voltage dividers here, so we have around minus 5 volts and plus 5 volts on the outside pins, and then we can go between those in the on the joystick and have somewhat 0 right up there. Minus 4 to plus 4 and 0 in the middle. Yeah, seems to work. And then on the output, that would give us 10 to minus 10, and that's because we don't have the range pot is not in place yet. So we need to add that. Okay, so plus 10, minus 10. Somewhere in the middle there. Offset it to 0, plus 10, minus 10. And we scale this. So minus 182, minus 2, and plus 2. Okay, so it works. Great. Now I need a panel, and I don't have a panel, so let's sit down and make a panel maybe. Alright, this is the panel I came up with. This round hole here is for the joystick. You have the X scale offset and Y scale offset. And then also I do have a CV input and CV input there, so I can actually have a modulation input that I can then add to or manipulate with this to just get the output then, or just skip the input and just use up here for the output. I also added holes for the an LED on both sides, and this should be a dual LED, and that should show either positive or negative voltage on the output. It's a nice feature that I saw on the Witch's Brew schematics that I might implement. Just another TL072 should add that to the schematics, and a few other components, of course. One thing that I should mention in this project is the joysticks I'm using are, you can find them on eBay, for example. They're replacement joysticks for Xbox controllers. I'll put the link in the description, but what you need to think about is that these are springed, so they always go back to the middle, and you might want that depending on how you do this, so you want to do that. But you can actually open these up on the bottom, so there's these little tabs. That's super easy to get to, but if we spend a few minutes bending these up, last one always needs to put up a fight. There. And then if you just hold your fingers, because it springs away. So here's a spring inside. If you remove that and put this back, let's see if we need to remove more. I think that is all you need to remove. So, and then you have a joystick that gets stuck in whatever position you place it in. So that is a good thing to know about these. If you want, they're really cheap. They're like $3 or something like that for a 6-pack, so quite a good price. So we begin with the basics. We have the dual VC LFO. I put that into the VCO1 SAW VCO by David Haliant, which I still haven't shown, but I'll get to that. So if we just take this one of the LFOs into CV1, we get this pitch going up and down, nothing special. So if we start with a simple one, just the scalar meter, to show what you can do with that. So we take the CV from this one into CV input of the scalar. Actually, we can begin by taking the CV output from the scalar into CV in here. You hear that the pitch changes, and here you can, with these two buttons with nothing connected, you can decide the center point and then how much, so the voltage basically out. And if I did have a meter on this one, this would show whatever voltage out I have, but I don't have that, so I can't show that. So instead we take the CV input, and if you thought about how much it changed the pitch before, you see that now it changes much less. And if we pull the CV amount up, then we get a much more difference in the pitch modulation. If we do the offset, we take that down a bit, then we only do something in the low end, and if we take it up, we just do a bit in the high end. So that's what this is. The offset changes where the center point of the LFO curve will be, if it's up here or if it's down here. And then you have the amount, that is how big the curve should be. So it's a really good module for that, because you don't always want full on the LFO. And actually these two could be on the output of the dual LFO, or any LFO. I think I even discussed that you should at least have a CV amount knob on the output of a LFO, because not modules have a CV amount on the input. So either you have one or the other, preferably both rather than none, I'd say. So simple module. Now let's exchange this for the joystick instead. Alright, so I have the joystick connected the same way, output, nothing on the input, and the output to the VCO1. And now we have control with the joystick. We also have control in the same way how much we want the joystick, so now it is quite fine-tuned. We can see this one. So this is the offset, this is the scale, so how much we should change the pitch. And we turn it up. Really sensitive there, so turn it down a bit again. Too much. And then we have the offset, that should be this one. So we're just in the low end. And going up here. And we're just in the high end. So that's how the same thing, we just added a joystick. We can, of course, add the CV again. So now we have the CV from the LFO. And we can, with the joystick, adjust. And but because it's a joystick, of course you want to use both axes. So let's change to another VCO. So we have two VCOs. Let's keep that one. LFO out a bit. that one is, I need to turn down the scale on that one because that is really sensitive. Yeah, so we have that, and then of course with 2 LFOs going in, and we complete this. So here's another patch. The second, so the first, this axis here is going, the CV output is going into the CV input of the dual VC LFO, the second one. First one is not used. So this one determines the rate of that modulation, which then goes into the second one. The second here, so I can choose how much. And that's what you can do with this, amongst other things. Of course you can control filters and everything else as well. So this turned out to be quite a long video again, sorry for that. There was a lot of stuff to discuss about this, and it's a good module even if you just do the scalar bias thing, or if you do the full joystick, portamento, modulation wheel, modulation foot, expression pedal, whatever you do. I think this is a good module to have to control things in your modular, to have just another input. So I'm not sure what next module is gonna be. I'm a bit there are so many modules I want to do, and inputs and controls, it's almost an unlimited amount of modules that you can do. But I also want to move forward to the next day, which will be effects. So we'll see, either it's another input module or we finally start with the effects. We'll see. Hope you are all well, staying safe, getting creative now after you've rested a bit over the summer, I hope, and I will see you all in the next video. Take care.